Hello everyone, this is the fourth lecture of the data science series using Python. In that lecture, the topic are data preparation phases to the model the data. In this data preparation phases, the first topic is how to partition the data or Python. Partitioning split the dataset into subset, typically training, validation and testing set to evaluate the model performance effectively. The training set is used to build the model. The validation set tunes parameters or the prevents overfitting. Then the test set assesses final performance. Common split are the 720-10 to or 820 training test. Random sampling ensures subset are representative, while the stratified sampling maintain category proportion. Proper partitioning ensure reliable evaluation and minimize data leaks. The second topic is how to balance the training dataset in RPython. Data imbalance occurs when one class significantly outweighs others, skewing predictor models. Balancing techniques include undersampling, reducing the dominant class, oversampling, replicating the minority class, or using methods like smooth. Synthetic minority oversampling techniques to generate the synthetic samples. Balance the dataset, improve the model accuracy for the minority classes, critical in applications like fraud detection or the medical diagnosis where the misclassification carry high cost. These are the technique for the balancing the training data set. First is the oversampling, second is undersampling, third is the hybrid approach, fourth is the class weights, and fifth is the in-sample. Let's see the example of the both. Demonstrating the decision tree using Python library. First of all, import pandas pd sklearn.models selection, import training test. These are the output of this code. Okay, the second is the partitioning data into training and the testing set using. First of all, import pandas pd from sklearn.model selection imports training data equal to this, and these are the output of this code. Features 1, features 2, training level. The third topic is how to build a card decision tree using RPython. CARD stands for the classification and the regression trees. It is a decision tree algorithm that splits a data recursively based on the variable that minimize impurity. Example, Gini index or the entropy for the classification, least squares for the regression. Cards create interpretable non-linear models, making it effective for the complex data. Pruning is often used to simplify the tree and prevent overfitting. The next topic is how to build the C5.0 decision tree using RPython. The C5.0 algorithm is an improvement over the earlier C4.5. It builds tree using entropy to identify split, but it faster uses less memory and incorporate boosting. C50 handles categorical and the continuous data efficiently, includes weighting of attributes, and produce smaller, more accurate models. It's favored for the scalability and flexibility. The next topic is how to build a random forest RPython. Random forest combine the multiple decision trees using bagging, bootstrap regression to improve the prediction. Each tree is built on a random subset of a data and the features, reducing overfitting and enhancing generalization. The final prediction is derived from the majority voting classification or averaging regression. Random forests are the robust, handle missing data and the rank features important, making them versatile for the diverse dataset. The random forest command in Python requires a response variable for the method as one dimensional array. So we used numpy reverse command to create that format. We use the random forest classifier commands to create the random forest. As before, the random forest classifiers command sets up the parameters of the algorithm. The n estimators input specify the number of the trees to be built, while the criterion equal to Gini specify the Gini index be used to determine the best split. The fit command uses the predictor variables x and the target variables y to build the actual decision tree. Save the result as the RF01. To view the classification made on the training dataset by the random for the EST algorithm, use the predict command rf01.predictx. Let's see the example of the random forest.py. Building a random forest classifier for the using skitlearn. These are the example of this. Let's run this code. Let's see, the output is the random forest accuracy is 1.